All right, so in our last couple of videos, we spent some time working on getting support conditions defined. Were they nodes? Were they not nodes? And do we need to be looking at, how to draw their respective shapes, their screen representation, if you will. We talked about pin supports, we talked about roller supports, and we talked about our fixed supports. The next piece that needs to be drawn on the screen has to do with our loads. So if we start out with, say a very simple supported beam, it looks something kind of like that, where we have a pin at the left, let's call that as A, and then B, oops, my autocorrect is something like that. Then the simplest type of load that we would have would be some sort of, point load that we'll call as some force P acting at some location on the length of this beam. So what I'm going to do is I'm going to call this as some distance as little a. Let's go ahead and say that the entire length of this is L, and just since most of what we're going to be doing is off of the left, we'll be measuring X as a dimension from the left end, that this is our reference that's here. So that would be everything that we would need to be able to figure out where on this structure are we looking at applying this point load. That's the first case. The next case that we might have might be, instead of being some concentrated effect on this, that now maybe instead I have some distributed effect. Okay, and so I have, this would be a uniform setup. Again, this is my support A at the left. Here's my B. And now we have something with an intensity, say, of W on this. And then if my beam is still L long, all right, then we need to be able to figure out how do we locate that load and tell it where it's from. So I'm going to again say that our reference is here at X, from the reference at the left end, or something kind of like that. And so if I know this dimension, and maybe we call that as, D1, okay, and then if I know this dimension that we could call as some D2, or something kind of like that, that would be enough to be able to define the load. But what happens if all of a sudden, instead of being uniform, my load is some other order? Okay, whoops. Say I do this, and I do, this is my load that now it varies. It's a linear load in which it varies with height X, and so this would be W naught. And then again, I would have to be able to find this point and this one. And again, if this is my reference, that could be my D1 dimension again, and this could be my D2 dimension that looks something kind of like that. And so we would have the ability to be able to then, come up with whatever between these three sets, we would have the ability to be able to define our typical loads. But what happens if instead we need to do something a little more generic? And again, we're kind of getting ahead of ourselves on some of this, but these are things that we need to kind of think about going into the future. What if my load looks something kind of like this? That instead of being uniform or linear or something fairly simple, this guy is now W as some function of X. Oops. Handwriting is terrible tonight. Sorry about that. Let's try this again. W as a function of X. It looks something kind of like that. And again, this might be my reference, and I'm measuring X off of that. And we would need, again, if this is where it started and this is where it ended, then this would be D1. And then the second point is measured as D2 along the length of the member. So those are some of the kind of the way that so we'd have to come up with a way, well, how do we define this function? Do we make it as a vector? Do we say that all of our loads are always going to be polynomial form? X squared plus 2x plus x defines the line. We've got to come up with a way to be able to kind of define that. But this is the more generic one that we want to kind of look at. Now, as I mentioned earlier, we're going to start off fairly simple just to see if we can get this thing working, and we'll stick with the point loads. But we've got to come up with how do I answer that question? So I see that being an issue going forward as we start to kind of look. Now, if we go in and we look at this, let's think about, you know, if we have, you know, some sort of, some sort of base load kind of class. Okay, well, we would need, some sort of an, a double D1, a double D2 on there. We would need probably some sort of load shape variable. Okay, and I could see doing this as an enum again. So if we write that one over here, here's load shape. And we could have things like, concentrated force, concentrated moment, have some sort of distribution, uni force, dist, lin, force. Get these all in there. And you can see we can start kind of using those, and then that can dictate how to draw or how we work with that. That there's, some sort of load shape parameter that comes off of that one. Okay, we would need to have something that would, potentially, how do we break the loads up? So if we took it back to our base elements, we would need, the difference, I guess, between, say, doing this guy, autocorrect for one, with something kind of like this versus, say, one that's not, where this is some W2 and this is some W1, something that kind of looks like this. This would be, a W naught, that this would be a more general, and maybe those two, W1 is not equal to W2 as our general definition. So we would probably need some sort of double, W1 and a W2 as our intensities for those. And that's kind of where we're at. And this would, this could be, positive or negative, which would dictate the direction of the effects. But once I know all of these, the other thing that we need to know is, what if we have multiple beam segments? Okay, which segment is it on? So there needs to be some sort of identifier for, a beam number probably, which I think we were doing those with ints. So we do a double, or whoops, what am I doing? Get ahead of myself. Int, and again, we'll probably change the variables, the name of these, but the beam number that it's assigned to. And so with that, and so D1, this is measured from our reference start, measured from start. So the start node will matter on those as we start to kind of play. But those are the pieces that I see being needed for a base load. If we have, in the case of, our point load that was happening up here, oops, back to draw so you guys can see what I'm doing. Our point load that's acting up there, then maybe we only need one of the D1s and we only need one of the W1s. So we would have to kind of come up with a naming convention for how we handle those. But I think that's where we're going next, is we're going to work on getting that class set up, getting it assigned to a beam number, and then we'll work on, well, once we get down there, this guy's going to, oops. We'll have to have some draw method for him. So the base load clearly is going to inherit from iDrawable. Okay, and that would be kind of the way that we have those kind of things. So the other thing that we might look at doing is, instead of doing just a base load, what would happen if we came in and said that we have our base load class that's happening here, Okay, that's our superclass. And then out of all of this, now maybe I come in and this guy now branches out and I get, a point load, maybe a point moment, a distributed load, and all of these could inherit out of this guy as a distributed moment. And then this guy could be, out of this one for the distributed loads, maybe it goes in, it further splits into, a line load, a uniform, and so forth and so on. And then the same thing for our moments might do the same thing. But again, this is getting way down the road ahead of where we want to be, line, uniform, and look something kind of like that. And so here are my other classes that are inheriting something kind of looks like that. So maybe that's the hierarchy that we do with our load. And then this guy then is pulling from, our I drawable there. And maybe that's where we're headed with this. Well, I think I didn't kind of play with it. I see benefits of doing both ways. This is the guy that has the draw function. But, eventually we're going to have, some interface probably for calculating their effects. What's the value of the point and moment, the moment of a point load with respect to a certain point? That's a whole nother discussion when we get into the calculations. But for now, we're just looking at being able to draw these things. And I think this is where we're going to have to go then for our load case. So with that being said, I think now we're ready to get rolling. So let's go take a look and we'll open up Visual Studio and we'll start to set this up. So, all right, here we go. All right, so here we are back in Visual Studio. And as we mentioned, our goal here is to try to come up with our basic loads, kind of a definition, how to assign them to members. And maybe we'll do a little bit of drawing here at the end. So the first thing we want to do as we start to do this is obviously create our base load model. Because I think we're going to go through the inherited form that we showed you where we have different types of loads that all inherit from a base load type of object. So I think that's how we're going to try to do this. Again, we'll get it up, we'll get it working, and then we'll refactor this a little bit, but it just seems like a logical choice to be able to do stuff. So, all right, so we're going to add a class, and we're going to do a VM base load. And so that we'll put that in there. We'll make this public. All right, and then Control R, Control G to clear all our other stuff. Probably do want a public enum load types. Get those in there, and we'll make a couple of defaults. Load fixed force, make that number 0, and then load type fixed moment as a 1. And fix is probably not the right word. Let's do, how about concentrated force? Oops, there's my printers. Okay, concentrated moment as a 1. We don't want a semicolon on this, we need commas, right? That'll get us that, and then load type, distributed force, and then load type, distributed, type, distributed moment will get us those. So that's a few to start, and then maybe we'll do a load type undefined for other stuff. Now, again, we can add to these all that we want. It's just we're looking for ways to be able to represent and work on those things. All right, so that's what we have for that. Now, The items that we need to know, as we talked about, is that they're for probably the base load object is going to need a private, and then load types, and then member load type. Okay, I'm going to default that to load type undefined for now, if it'll let me do that. Oops. Load types dot. That gets us that one, and then in the constructor, it's going to need a couple of arguments. What are we going to need? We're going to need a VM beam object. We're going to need load types, load type object, and then we'll need some parameters that were double. Let's just call it D1. I think I called it A in the OneNote video, but the dimensions from the start. So D1 is the start of the value from load from the end, or from the start node. Double D2 will be the distance of the end of a distributed load. And again, it's kind of what goes in this. We'll put it all in here for now, but like I say, I think this has got to get factored out a little bit further. We need the intensity double intensity start. Okay, and then double intensity end. And just so we're constant, we'll call that W2. Call this as W1. That gets us this one. And I think that will cover that. Oh, and then we need to do our drawing objects. I said drawable also. Drawing objects because we want to be able to draw this guy. And then we'll add him. There's our interface. And then we'll control dot this to implement the interface. And there's our draw for this. Okay, and so for now, just so we get something to show up, we can do drawing helpers. We want the helper dot draw circle, and then we need our canvas C. We need our X coordinate, which for now we'll just do as we gotta add a couple other things first before we do this. Let's get our beam object, so a private VM beam, and this is our member beam that is gonna own the load. Now, one issue that we have is what if it's a nodal load? A load that's applied to a node, not to a specific beam. So we'll have to kind of work on that as well. But for now, like I say, we're just gonna kind of play with this. Yeah, take a sip and get a little bit of a frog in my throat there. Okay. Okay, and this is, we'll set it to null on creation, and then we can go RM beam is a beam. And our M load type is our load type. Oh, excuse me. Oh, excuse me. Sorry about that. As you can see, it's me coughing on screen, but at least I muted the mic, right? Okay, so that will get us that. And then, we do need to get some values in here. Private double D1, D2, W1, well, D1 equals 0, private double D2 equals 0, and I know it defaults to 0 as a value, but again, double W1 equals 0, and a private double W2 equal to 0. That gets us those. So distance from start to start of load, distance from start to end of load for distributed loads, intensity at start of load, and intensity at end of load. That allows us to define our distributions. Now again, this is assumed up to a maximum of a linear, and there's going to be some things if we want to get into generic loads that we'll have to kind of tweak this a little. But again, we're starting simple, and then we'll ramp it up in the complexity as we start to go through here. All right, so we want to draw our circle, and then we want to do our, well, for now we'll just do it at, how about beam dot start dot x plus d1 and m beam dot start dot y. Okay, plus, well, again, we'll just do d1. We're just trying to get a marker on here more than anything. Our fill is a brushes. We'll make our marker. In fact, I think I'm going to make that a circle hollow. Brushes dot. What's a good color? Do kind of an aquamarine blue color on that. So that got us our stroke, and then our radius of, let's do 15.0 for that. That will get me that guy. So that draws us, that draws our object. And that's the load that's on the beam. Or should the beam own the load? Now that I think about it. Well, we'll see. Okay, that gets us to that guy. So let's go through, let's go back to where we created on user create, where we're creating all this stuff. Where do we make our beams? We added our beams. And so let's add a new load, which would be VM base load, load 1 is a new VM base load. And the beam that we want to do, let's do the first beam in the list. Okay, and then our load type is load types dot, let's do a concentrated force. And then we'll do that at a distance of 10. We'll do this at a distance of 20. Do this at a distance of 5. Do this as a distance of 5. And I need to cast that guy into a VM beam because it's an eye drawable, not the other. All right, so that should get us a load. Okay, so draw the nodes, draw the load, or draw the beams, and then we're going to draw the loads. And we're going to make a, let's do VM base load item in loads. And then we're going to do item dot draw and put that on the main canvas. And then we need to go add public list eye drawing objects. Okay, and then we'll do loads, and then do get set on that. And lost focus event manager, that was not what we wanted. How about a list? There we go. So, all right. So that gets us another object to be drawn. And so if I run this, does this draw us our little blue circle? Oops. What did we miss? Oh. This and a semicolon. Yes, we are. Right there. All right. Run it. Oh. And I know what I did. Made a list. Forgot to initialize the list. So here. Do that just about every time I try to make a list, because I always forget to initialize it. Drawing objects. That gets us. Yeah. In fact, we could probably move that up into this right off the bat, and then I don't have to have it on user create, but that's fine. Anyway, let's try it again. Oops, stop. There we go. Do we see our load anywhere? I wonder if I pulled in a bogus coordinate. Oh, forgot to add the load to our list. So let's go loads dot add load 1. Same problem we had last time when we were playing with the supports, I think. Save that, try that. There it is. A little, hopefully you guys can see it's a little bitty blue circle up at that start node. So that's the indicator of our load. And again, we're not worried too much about positioning and that kind of stuff on there, but at least we're getting the load object created at this point. Okay, now how do we want to handle everything else? So loads are kept in their own array. It'd almost be nice to have the beam know what loads it has, but I think this uncouples everything a whole lot better. So let's keep it like that for now, and we will go with that. Okay, all right, so that gets us there. All right, so now let's figure out how do we want to draw this load. So I think we're going to go through and we're going to add a new drawing helper. All right, so let's do a public static void draw arrow down canvas C double X double Y double Z and then string. Do we need a string? We don't need a string. We just need really that. We'll have some default size. How about a brush fill and a brush stroke. All right, and this we don't want to do a void on that. We want to make that a shape. But it's not it's a compound shape. Yeah, let's just leave it void, and then we'll figure out how to. Maybe what we'll end up doing is creating a generic image, like a BMP or a target renderable or something, and create our arrow, and then we can just reload those as we needed to. I haven't quite decided on that either. Double brush, don't need a double there, do we? Okay. That will get us that. Why are you hollering at? Oh, stop our chain. Remove, you're yelling at me for those. Alright, so for now, let's just take our line code. Yeah, so we'll just drawing our arrow. Let's do draw a line. We're going to go from our x coordinate onto our canvas, from our x coordinate to our y coordinate, and then we're going to go to our x coordinate, and then we'll go upward y minus 10. Alright, and then we'll do brushes dot. Again, let's just do aquamarine, make it fun. And then our stroke is well, since we're not filling the region, we'll do that. So that's our line. Okay, and then we'll do a draw line. And now we'll go from our contact point X, Y. In fact, maybe we'll make this a little bigger. Let's make this 20. 20, and then we're going to go X minus 5. We'll do Y minus 5 as our end, and then our aquamarine, and then we'll do another one, draw a line, and see X, Y for the initial install point, and then we're going to go to X plus 5, Y minus 5. Should give us a very basic looking arrow. Again, don't necessarily like it, but we're looking more for functional at this point. X, lost a comma. There we go. That'll get us there. Let's go back to... What in the world is it doing? Oh, don't you dare blow up on me. Whoops. It crashed. Fan-freaking-tastic. Still got that. See, what did we lose? Did we lose anything, or did it save? Oh, I did save. Good. I haven't had a Visual Studio crash in quite a while. Alright, so that was our circle. So now we want to go back to our base load. And instead of doing a draw circle, we're now going to do a draw arrow down. I think. Why? Go first dot. Draw arrow down. There we go. I'll put you on there. Nope, you're blowing up on me. And I don't. Canvas X, Y, brushes aquamarine. Alright, then back to our helper real quick. So instead of this, we're going to do stroke on you. Stroke on you. And we'll do that. And we don't necessarily need fill anywhere. All right. And that will get us that one. And you can see we got a little bit of an arrow up there in the middle. Very cool. Okay, so that gets us a very simplistic arrow down. We want to do... Let's do our arrow up while we're here. Draw arrow up. And because we'll be needing that when we start drawing free body diagrams. So now it's going to be a Y plus 20. And a Y plus 5. And a Y plus 5. All right, compiled. We do want to go back and change the color because that is a horrible color. Where's my base load? Then I'm going to go ahead and make it black just so we can see it. I'll get us that. And for the sake of argument, draw arrow up. Instead of doing a start, we'll do this one at the end. And do that one at the end. And now we'll get there. So you can see we're getting our arrows put into the picture, so that's okay. All right. Now, looking at this, I can see the need for some other helper functions. So we've got helpers for the start, and we've got helpers for the end. Let's go make one for the midpoint. Public VM node. Do I want to make that a node? The node is a node. Go back and did I define the node as a point? Node is a node, but a point is a point. That's a deep thought, right? So it's just the X. Let's do private double m midpoint x ordinate of our midpoint. I really don't want to make a node. Well, I guess we could. Yeah, I just hadn't thought about that. Midpoint X. VM node. Midpoint. Let's just go ahead and make it. VM node. Midpoint. If we want to get, we're got a midpoint, and if we're going to set it, then we can do m midpoint dot x equals start dot 0.5 times start dot x plus n dot x. That gets me the average location, and then I could do m dot y equals 0.5 times start dot y plus n dot y gets us that guy. And that will get us our midpoint. And then in our constructor, that's a tough one. Midpoint equals a new VM node Where's my other? And this is where I want those formulas. Control V, Control C, Control V, and then it isn't undefined because it doesn't have a support at that location, so that's our midpoint. And midpoint equals values, the better way to do that. There we go. So I'll pass the value into the midpoint function, but we're going to create a node. Like I say, we're trying to avoid making superfluous nodes, but the midpoint one is handy enough, and I think that's worth working on. So, all right. So then we can go back to where we were making our load. And where are we? We're going to assign the load to that guy. And then it's the base load. Let's do beam.midpoint.x. Midpoint.y. And we'll do the same thing on this guy. There we go. And that should put us a load in the middle of our beam. It's even on the angle. So we've got an arrow up and an arrow down, and that's what we wanted. So we've located that point. Again, it kind of monkeyed with our numbers here, which I'm not a big fan of, but for now, I think that will work on that. So that gets us how to draw our point load instead of the base load. So, but that's very specific to not just a basic load. This draw function can't be used for our okay. Yeah, it can't be used for a distributed load. So let's do, how about within this one public class, VM point load, which is also going to inherit from a VM base load. VM, we spelled it. Put that on there. Let's stop our and we want to do so I gotta pass it a beam, don't I? And we need a constructor. It says that one, and then we want VM beam that goes. Can I do VM base load beam here? Can I do beam? Because it needs the same signature. Control C. Control V. Beam. load type D1, D2, W1, W2. And take that off of there. What if I do that? Alright, yep. So, yeah, you don't call it by the base class name, you call it as base, and then that passes all the parameters through. Alright, so now I can do public void. Can I do an override? Void draw canvas C. And look at all of you guys. Public. How about a virtual void? That got us that. Alright. So that got us our virtual function that we're overriding. And then this guy, I probably can't see that because it's private. So we'll do a getter. Okay. So public VM beam get return and beam, and then set and beam dot set and beam equals value, not validation error, value. That gets us our setter. And then I can do beam here. Probably ought to make load type. Load type. And then M. And that is the load types, that one. There we go. Got lazy and didn't do that right. Alright, so there's our base load. Okay, and so then this guy can be a beam, because now I can get to it. View and view. So it passed all the values through, but now I can't see it. All right, let's go make some more setters. Yay. And D1. Let's just call that D1. It says that. Why are you? And you're a double. Got that. Make you a D2. Make you a D2. And you're a D2. And you're a W1. W1. And you're a W2. 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 That will get us those parameters. And again, I'll go back and add the comments to what those are, because I'll probably forget otherwise if I don't. Okay, so that gets us to that. Plus D1. Plus D1. D1. And that gets us that. So let's run this and see if it works. And we lost. So it's running the default here. So if item dot load type is load types dot concentrated force. I don't know why it defaulted to that. Turn that off. How do I force that to draw? Can I do... what did I call that? VM point load. Cannot convert a type void. There we go. So yeah, so you just gotta remember I gotta cast the item and then call the draw function. So that's why. All right. Whew. One of those nights, guys. But I think that should get it back for us. Or not. What didn't you like? New, oh, this should be a new VM. Point load. I think that will, whoa, whoops. There it is, that worked. Okay, so we're still got our arrow, so we got load arrows showing up on that. And we'll start worrying about values and those kind of things. One of the things we have to look at, especially with regard to the point load, is we've defined the intensity as being the same. Can I call a point load as a distributed load if I make those 2 points the exact same? What would that do for us? Because I'm going to be doing some average calculations later on, just kind of thinking out loud here. I think we're okay for now, but so we've got our loads created, got them assigned to the beam as objects. Is this the best way to separate the loads out from the beams? I'm not totally convinced on that yet, because I have coupled the load. The load knows what beam he's on, but the beam doesn't know that it has a load. And it seems like you would want that to work both ways. I'm going to have to think about that. We may have to address that in a future video. But for now, I think that gets us what we want as far as getting loads created, getting arrows drawn. Pretty simple stuff, really. As always, thank you for your time. Thanks for coming out. And we'll see what happens in our next video. I think next time out we'll starting to draw the graph and maybe even doing some calculations now that we've sort of got things located. One of the things we have to look at is there's no logic or error checking in this function call. What if that dimension is longer than the length of the beam? That could be a problem. So we've got to kind of figure out some ways to work with this. But we've got the functionality, now we just got to get the logic and the error handling in this. So this loads is going to be a multiple part deal to get that squared away. And how do we store that information and those kind of things. So we'll figure it out. We'll get it handled and we'll figure it out. So thanks for coming out tonight. We'll see you guys in our next video. As always, if you found this entertaining or somewhat useful, please think about giving us a thumbs up and helping to spread the word on the channel and on this series. Like I say, we're getting faster, getting better. But hopefully you kind of see the ins and outs of what it is we're doing. I know it's a very low level thing. I'm not the fastest, the most eloquent of coders, but I think I can get the job done. So that's what I'm hoping for. So, alrighty. Have a great evening, and we'll see you guys next time. Bye now.